In this video, I will show you how to use the chaos destruction cache to vertex animation tool that is now part of EasyVertex Anim plugin. So here we have a little example level located in the Apple project Evo Demo Maps. And this is a little example to show how you can use the vertex animation texture to play some destruction animation efficiently. If I hit play, you see this was the real chaos animation, what we recorded into cache and transformed then into a vertex animation texture. And here is the real world use of this vertex animation texture. So when I fire the ball on those columns, it will destroy it by playing the animation. So the goal of this, of course, is to make this destruction lighter than the playing the chaos animation and or playing the chaos cache. And those two examples are one made with a blueprint. So each column has a blueprint that detects when the ball hits it or the player hits it and explodes. And this one is even more performant. Those are just foliage of those columns. So there's instanced static meshes. And the ball detects when it hits one of those and then play the vertex animation on them. There are a list of animations it can choose randomly from, and then removes the instance from the foliage. So now I will show you how to set up the baking process, how to bake the vertex animation, and how to use it. Now let's look how to use the tool using this chair. So we'll first create a destruction effect with chaos, and then we will save it as a vertex animated texture. So first of all, we will put this chair at 0. That will be important later. And then we will create a fracture. So there's a lot of tutorials and documentation how to create chaos destruction. I will not go into detail. I will keep it simple here. So first we will create a geometry collection, and I will rename it as GC chair to follow Unreal standards. And we can see it was created here in this folder. And then we will fracture it. And that's it. We created our fractured chair. Done. Now we have this. And this is now, it was replaced by the geometry collection actor. So it's not more the static mesh. Now I will just take this and put it here to keep things simple. Okay, now we have this geometry collection chair that looks exactly the same, but if you go into wireframe mode, you see that it's fractured. Now, next thing, we will create a little explosion. For this, we will go to the engine folder and search for master. And you find this blue sphere, master field. You put it somewhere here. This will say to chaos to do something, to explode the chair. Back to our example folder. Okay, now if I hit simulate, the chair will explode. So we will just dial the explosion strength a little bit down. Okay, that's good. So that's the effect we will transform into vertex animation. First, we need to record it as chaos cache. For this, we will take our geometry collection, chair, and then here go to actor, chaos, create cache manager. And it asks us where we want to create this cache asset. We will create it in the same folder. And then now, if we check our cache manager here, we'll see it's ready to record. Cache mode record. So now if we play again, simulate again the level, the chair will explode and the cache manager will record it into cache. And that's it. Stop. Fine. Now we recorded the chair. You can see it here. If we do play, it's recorded. Good. And that's it for the setup of the explosion. So we created the geometry collection, we simulated the explosion, and we recorded it into cache manager, which put it into this asset. Now we need to transform that to the vertex animated texture and the mesh. For this, we will again choose our chaos manager because it references everything we need, the chair and the cache. We will go into modeling mode, EVA, and there's the new tool. As you can see here, it has two parts: generate mesh and generate textures. So generate mesh, you basically use once to generate the static mesh that looks like this that looks like this geometry collection, has the same structure, it's fractured, and then those are the textures. So here I will simply generate the mesh and I will select the V channel 1 because this chair only uses V channel 0. So we will put our vertex animation UV into 1, but you can choose also 2 if your mesh already uses channel 1. And here our texture generation settings. So here we have FPS at which we will record it, resample the cache, and then we can start a little bit later, for example, and finish a little bit sooner. And here the textures, if you let them empty, it will create new textures, and if you already created some textures and you want to overwrite them, you can put them here. And there's two textures, one for the locations and one for the rotations of the animation. Now I will just click accept, and here we are. We have our static mesh and we have our two textures. So the static mesh, if I look into wireframe mode, you can see it also has those fractures. It's exactly the same structure. And now interesting things, if I go into UV editor mode and I look into our UV channel 1, you will see nothing like this, but you can see all those UVs here, they correspond each to a part of the chair, to a fragment of the fracture, and it's exactly made the way that the texture, each each line in this texture correspond exactly to one fragment of the fracture, and it records its movement during the time. So this animation for the first chunk, the second chunk, etc. You can see this texture, very, very small, took 24 kilobytes, and our data is here. It's a data texture. Okay. Now we have to play our animation. And for this, we need to modify the material of the chair to add the world position offset into it. So we'll create here, as usual, we will create a make attributes node, and then just base color, metallic, roughness, and normal. Put them here. And then we will, like with EVA, the other tool, create a material attribute layers, and then use material attributes. And here we can directly put our vertex animation layer, which is called ML cache to VAT2. So there is two of them. One use two textures like we generated now, and there's another that use one combined texture. So that's all. Now we will create the instance of our material and configure it for the vertex animation. So put it here. Layer parameters, we have our layer, ML cache VAT2. And here we have to put the textures of the animation. And we have to put the here we will choose control time to directly control time in the parameters. It will be easier to demonstrate. And here we will check has normal map, because this chair has a normal map texture. And then here, in case you choose another UV.1, you can select it. In our case, we choose it 1, so by default it's also 1, but check it 2. And that's it. We have our material instance that we will now put on our chair. And we can play the animation. If we change the time, you can see it will explode, exactly like the simulation did. So to avoid those shadow artifacts, as you can remember, if you use it even before, I explained that before, you have to extend the bounds a little bit. You can also do that in the model. And now it works. So here there are some more parameters that are interesting. So there's this interpolate parameter. It will use the linear interpolation of the animation. So instead of taking one frame at a time, it will interpolate between 2 frames. And it will look smoother at any frame rate, because as you remember, we recorded at 30 to spare some space. But if you interpolate, it will be smooth even if you play 120. The problem with the interpolate, it works well if the simulation is like this, if there is nothing that rotates too fast. If there is something that rotates too fast, the linear interpolation will probably produce some artifacts. So take care of this. And then the other thing we can change here. So here we're using the control time mode. We're controlling this time directly. You can do it like this, or in your game probably from the blueprint or code. But there is also another mode. If I disable this, the mode is start time. So if start time is -1, sorry, it will just wait that the start time is set to something. If it's 0 or more, it will start playing the animation at this time. And this start time, you obtain it in your blueprint, for example, by normally using the get game time. And in this case, I put it to 0. So here you see the animation is already finished because 0 was before. And if I hit simulate here, it will start every time at 0. So if I put here like 2, it will start later. And the idea here is that in your blueprint, on your code, you will set this parameter of the actor you want to explode to some value like get game time, and from this moment on it's the same. In the material, from this time it will start to play animation and explode. And there's another thing, probably once it exploded you want it to go away. And for this it's also implemented. You have to change your material to use masked blend mode. And then you can see already disappeared. Now we do it. Now I will put here 0 back. Start faster. And finally, there is a parameter here that appeared that says use custom data. And this is if your chair is a part of instance static mesh. And in this case, you can, for each instance, set the time. So you cannot do it anymore in the material. You need to use the custom data, for instance, custom data in the blueprint. And you start it like this. Again, I will set control time and just show it again one more time. And finally, let's see, we want to create another animation. For example, we can simulate it again. For example, there's something didn't work well here with the cows. Was some strange movement. We simulate it again. This was okay. And then we can go again, choose the cache manager, and we don't need to regenerate the mesh. We can just generate another couple of textures. You see it added 2 other textures. And I also can take this and like take those two textures, put them here, and they will be overridden instead of create new. Finally, I would like to briefly explain how those two examples are set up. So first, this one is simple. It's each column, it's a blueprint. And in this blueprint, we react on the hit on the overlap, and we call this destruct event, which basically will set the lifespan of the column to the duration of the animation. And then it will, for each material, because there may be many materials, it will call the set scalar parameter value by info to get game time in seconds. So the destruction animation starts to play immediately. And here to pass this parameter to the layer, we will say start time, layer parameter, and our layer 0. And here, as we have actually many animations, we recorded many different animations. They are stored in those two arrays. You can see here, and it will choose one at random and set also anim location and anim rotation to that. And the other example, it's more complicated. So this is just the foliage, really. And when the ball hit the one of those things, it will remove the instance and call another blueprint, which is a global blueprint in this level called boom manager, which will create instance of the exploding mesh and then set the custom data value at index 0 to also get time in seconds. And that's how all this stuff is set up. And the result, as you already seen, is that you can go and explode all this stuff like this. So here it will just remove the blueprint from the level after the animation played, and here it will remove the instance from the foliage and then add another instance in those boom manager actor, which will play the explosion animation and then disappear. So that's it. Thank you very much for watching. I hope it was clear enough, and if you have some questions, please don't hesitate to ask.